Currently, more than 25,000 Australians are diagnosed with multiple sclerosis, or MS. Globally, more than 2.5 million people suffered from this disease. That's more than Perth's population in 2015. MS is an autoimmune disease. It means that your immune system is attacking yourself. In MS patients, their immune cells are attacking their central nervous system. MS patients will experience neurological symptoms, including progressing paralysis, and more than half of them will be disabled 10 years after their diagnosis. Unfortunately, we still haven't found a cure for MS yet, and the mechanism of this disease is still unclear. But don't worry, we are working very hard on it. And this is where I come in. My PhD project is trying to identify the cause of MS in hope of finding the cure. One of the interesting immune cells that I'm looking at is the B cells, aka the antibody factory. A drug called rituximab, which works by lysing circulating B cells, seems to be effective in treating relapsing remitting multiple sclerosis. Interestingly, a history of previous Epstein-Barr virus infection seems to be a significantly consistent risk factor of MS. Yes, this is the virus that causes glandular fever. Once you have been infected by this virus, your body can never get rid of it completely. This virus infects the B cells and then stay inside the B cells for life. EBV-infected B cells shows the characteristics of activated B cells and acquired immortality. So, the question now is, does immortal and activated B cells can cause autoimmune disease like MS? To answer this question, we have created a mouse model where the B cells are immortal and activated. To do this, we inserted two genes into the mouse. Let's call it gene B and gene C. Insertion of gene B will cause B cells to acquire immortality, and insertion of gene C will cause B cells to be activated. So, mice carrying both of these genes will have immortal and activated B cells. We hypothesize that these mice will develop a spontaneous experimental autoimmune encephalomyelitis, or EAE. This is the equivalent of MS in human. And guess what? Our first mice carrying both of these genes really did develop a spontaneous EAE. It seems that our hypothesis is right on the money. Although this study is still in the early stage, it shows that B cells could be a potential target for developing the cure for MS. Thank you for watching, and I hope you learned something from this video.